ANSI/EIA/TIA 607, published in 1996, defines requirements for grounding and bonding of telecommunications systems. It covers several important topics. Firstly, bonding requirements for both copper and optical fiber conductors are addressed, ensuring that all conductive elements within the telecommunications system are properly connected to create a low impedance path for fault currents. Secondly, equipment grounding requirements are specified, detailing how telecommunications equipment should be grounded to minimize the risk of electrical shock and ensure proper operation. Thirdly, the standard provides guidance on protection against lightning and electrical faults. This includes the use of surge protection devices and other measures to protect telecommunications equipment from damage. Fourthly, testing and inspection procedures are outlined, providing methods for verifying that the grounding and bonding system has been installed correctly and is functioning as intended. The standard is designed to complement the grounding requirements of the National Electrical Code, specifically Article 250, by providing more detailed and specific requirements for telecommunications systems. ANSI/EIA/TIA 569, also published in 1996, provides standards for the design and installation of telecommunications pathways and spaces in commercial buildings. This standard covers a range of topics relevant to the physical infrastructure that supports telecommunications systems. Firstly, pathways for telecommunications cables are addressed, specifying requirements for cable trays, conduits, and other pathways to ensure that cables are properly supported and protected. Secondly, telecommunications rooms and equipment spaces are covered, outlining requirements for the size, layout, and environmental control of these spaces. Thirdly, electrical safety requirements for telecommunications equipment are included, ensuring that equipment is installed and operated safely to minimize the risk of electrical hazards. Fourthly, grounding and bonding are also addressed, including a section that summarizes the grounding and bonding requirements of ANSI/EIA/TIA 607. Both ANSI/EIA/TIA 607 and 569 complement the grounding requirements of NEC Article 250. NEC Article 250 provides the primary grounding and bonding regulations for all electrical systems, including telecommunications systems. The ANSI and TIA standards offer more specific requirements and guidance tailored to the unique needs of telecommunications systems, elaborating on the general principles outlined in the NEC. When it comes to separate earth ground, telecommunications systems should be connected to the building's electrical grounding system, which typically includes a connection to an earth electrode system. This ensures that telecommunications equipment is grounded to a common reference point, minimizing the risk of ground loops and other electrical problems. For lightning protection, telecommunications systems should be protected from lightning strikes through the use of surge suppressors and other appropriate measures. Surge suppressors divert excess voltage caused by lightning strikes away from sensitive equipment, preventing damage. Regarding isolated receptacles for UPS, telecommunications equipment, including UPS systems, should be connected to properly grounded receptacles according to NEC requirements. This ensures that equipment is grounded to a common reference point, minimizing the risk of electrical shock and ensuring proper operation. To gain a better understanding of the specific requirements outlined in ANSI/EIA/TIA 607 and 569, it is recommended to review the full text of the standards. These standards provide detailed information and guidance on grounding and bonding telecommunications systems. Compliance with all applicable standards and codes should be ensured by consulting with an experienced electrician or telecommunications technician. These professionals can provide valuable expertise in interpreting and applying the requirements of the standards. The NEC should be adhered to as the primary grounding and bonding regulation, as it provides the fundamental requirements for electrical safety. The ANSI and TIA standards should be used to supplement the NEC, providing more specific guidance for telecommunications systems. It's important to understand the interplay between these standards and how they apply to telecommunications installations. Telecommunications grounding and bonding serve several critical purposes. Firstly, they protect equipment from damage caused by electrical surges and lightning strikes. Proper grounding and bonding provide a low impedance path for fault currents, diverting them away from sensitive equipment. Secondly, they ensure the safety of personnel by minimizing the risk of electrical shock. Grounding and bonding create a safe path for fault currents to flow, tripping circuit breakers and preventing dangerous voltages from appearing on equipment enclosures. Thirdly, they reduce electrical noise and interference, which can disrupt telecommunications signals. Grounding and bonding create a stable electrical environment, minimizing the effects of electromagnetic interference. Effective grounding and bonding practices for telecommunications systems involve several key elements. Firstly, a grounding electrode system should be installed to provide a connection to Earth. This system typically includes ground rods, ground plates, or a combination of both. Secondly, a bonding network should be established to connect all conductive elements within the telecommunications system to a common ground point. This network typically includes bonding conductors, bonding jumpers, and equipment grounding conductors. Thirdly, surge protection devices should be installed to protect equipment from voltage surges. These devices should be installed at the service entrance, at distribution panels, and at individual equipment locations. Fourthly, regular inspections and testing should be performed to ensure that the grounding and bonding system is functioning correctly. This includes visual inspections, continuity tests, and ground impedance measurements. Specific components used in telecommunications grounding and bonding include ground bars. Ground bars serve as a central connection point for grounding and bonding conductors. They are typically made of copper or aluminum and are designed to provide a low impedance path to ground. Bonding jumpers, short lengths of conductor, are used to connect different pieces of equipment or different parts of the grounding system. They are typically made of copper and are sized according to the expected fault current. Grounding conductors connect equipment and the grounding system to the grounding electrode. They are typically made of copper and are sized according to the requirements of the NEC. Surge suppressors are devices that protect equipment from voltage surges. They are typically installed in parallel with the equipment they are protecting and divert excess voltage to ground. When installing and maintaining telecommunications grounding and bonding systems, several best practices should be followed. Firstly, all grounding and bonding connections should be clean, tight, and corrosion resistant. This ensures that the connections provide a low impedance path for fault currents. Secondly, all grounding and bonding conductors should be properly sized and installed according to the requirements of the NEC. This ensures that the conductors can safely carry the expected fault current. Thirdly, all surge protection devices should be properly installed and maintained according to the manufacturer's instructions. This ensures that the devices are functioning correctly and providing adequate protection. Fourthly, regular inspections and testing should be performed to verify that the grounding and bonding system is functioning correctly. This helps to identify and correct any problems before they can cause damage or injury. Grounding and bonding systems should be designed and installed to meet the specific requirements of the telecommunications system and the building in which it is installed. Consulting with an experienced electrician or telecommunications technician is recommended to ensure that the system is properly designed and installed. When dealing with sensitive electronic equipment, it is essential to implement proper grounding and bonding techniques to prevent damage and ensure reliable operation. Ground loops, which occur when there are multiple ground paths with differing potentials, can introduce noise and interference into electronic circuits. Proper grounding and bonding techniques minimize the formation of ground loops and mitigate their effects. The NEC provides detailed requirements for grounding and bonding electrical systems, including telecommunications systems. Understanding and adhering to these requirements is crucial for ensuring electrical safety and preventing equipment damage. Regular inspections and maintenance of grounding and bonding systems are essential for ensuring their continued effectiveness. This includes visual inspections of connections, testing of ground impedance, and verification of surge protection device functionality. Telecommunications systems are becoming increasingly complex, with higher data rates and more sensitive equipment. Proper grounding and bonding techniques are more important than ever to ensure the reliable and safe operation of these systems. The use of fiber optic cables in telecommunications systems introduces new considerations for grounding and bonding. While fiber optic cables themselves are non-conductive, the associated equipment and enclosures must be properly grounded to prevent electrical hazards and ensure proper operation. Wireless communication systems also require careful attention to grounding and bonding. Antenna masts, equipment enclosures, and grounding conductors must be properly installed and maintained to protect against lightning strikes and ensure reliable operation. In industrial environments, telecommunication systems may be exposed to harsh conditions such as corrosive chemicals, extreme temperatures, and high levels of electromagnetic interference. Grounding and bonding systems in these environments must be designed to withstand these conditions and provide reliable protection. Data centers, which house large amounts of sensitive electronic equipment, require particularly robust grounding and bonding systems. These systems must be designed to minimize the risk of electrical noise, interference, and equipment damage. In healthcare facilities, telecommunications systems are often used to support critical patient care functions. Grounding and bonding systems in these facilities must be designed to meet stringent safety requirements to protect patients and staff from electrical hazards. Educational institutions rely heavily on telecommunication systems for teaching, research, and administration. Grounding and bonding systems in these facilities must be designed to provide reliable operation and protect against equipment damage. Government buildings, including office buildings, data centers, and communication facilities, require robust grounding and bonding systems to ensure security and reliability. Grounding and bonding systems should be designed and installed to meet the specific requirements of the application and the environment in which it is installed. Consulting with an experienced electrician or telecommunications technician is recommended to ensure that the system is properly designed, installed, and maintained. Continuous education and training are essential for electricians and telecommunications technicians to stay up to date on the latest grounding and bonding techniques and requirements. Changes in technology and regulations can impact grounding and bonding practices, so it is important to stay informed. Grounding and bonding are critical aspects of electrical safety and telecommunications system performance. Implementing proper grounding and bonding techniques is essential for protecting equipment, ensuring personnel safety, and providing reliable communications. The information provided serves as a general guideline and should not be considered a substitute for professional advice. Always consult with a qualified electrician or telecommunications technician to ensure that your grounding and bonding systems are designed and installed in accordance with all applicable codes and regulations. Additionally, remember that specific local codes and regulations may vary and should always be considered. Effective grounding and bonding can prevent equipment damage, improve system performance, and reduce the risk of electrical hazards.